What can we do to reduce railway noise? Which mitigation measures should we adopt? To answer that, we need to know if we're dealing with airborne noise or ground-borne noise, because mitigation these two types of noises are totally different. In this video, we will share the principles and some examples with you. Let's talk about airborne noise mitigation first. The first approach is by blocking or reflecting the noise from reaching the receiver. The most well-known measure is constructing noise barriers or noise enclosures around the source. The effectiveness of such is based on how high and wide the barrier could cover. The second one is sound absorption. Sound energy can be dissipated into heat by sound-absorbing materials. It can be installed in noise barriers or on a tunnel wall to reduce tunnel noise from reaching the passenger. The third type is vibration damping. Dampers could be installed to reduce wheel and rail vibration before turning into noise. In some cases, resonance could occur, which creates a very irritating tonal noise. Tuned mass damping is the best way to suppress resonance. It enhances energy dissipation at a specific vibration frequency. Our Q damper does precisely that with excellent performance. The fourth way is to reduce vibration excitation between wheel and rail. One method is to slow down the train. But for changes to be noticeable, the train speed needs to be reduced by 25 to 50%. In many cases, the train has to slow down to reduce noise when there are space and structure limits to install other measures. So, how do we solve the problem without sacrificing speed? Our Q damper is the solution. Not only can it guarantee a 4 decibels A noise reduction, but it's also constructed without limitations on space and structure. Apart from train speed, rail surface roughness will also affect the vibration level at the wheel and rail. Rail surface becomes rougher due to damage caused by friction. In severe cases, corrugation will be developed. Corrugated rails have a wave-like pattern which causes rail resonance, creating a huge unwanted noise problem. For sections that are prone to corrugation, the rails need to be grinded once every 3 to 6 months to restore rail smoothness. In other cases, the rails would be grinded yearly. Our Q damper saves maintenance costs by reducing rail grinding frequency by suppressing corrugation. It's the world's first to suppress corrugation rate by 90%. Lastly, let's talk about principles to mitigate ground-borne noise. The most common approach is rail vibration isolation, which stops the vibration transmitting into surrounding structures. However, the vibration energy would have nowhere to go and remains at the rail, creating more airborne noise. Also, the vibration isolation structure is required to be built before train service commissioning. Therefore, if ground-borne noise problems are to deal with after commissioning, we will have no choice but to slow down the train in order to reduce collision forces between the wheel and rail. One of the major sources of ground-borne noise is P2 resonance, which vibrates at 30 to 100 Hz. Q damper is now proven to suppress P2 resonance, which was once thought to be impossible for rail dampers. We have made a breakthrough in the industry by making the world's first device that reduces ground-borne noise while being able to be installed after commissioning. These are the principles and examples to mitigate railway airborne noise and ground-borne noise. We hope you find this video informative. We will share more about the rail resonance in the next video. JBIS Innovation Limited for a quiet rail. We focus on research and development in acoustics products and services for the railway industry.